Here the question is, for a p-type semiconductor, which of the following statement is true? For solving or for answering, before answering this one, we want to know uh, why we can call that some type of semiconductor is p-type semiconductor, some type of semiconductor is n-type semiconductor. What are the dopants we are adding in those semiconductor? We are just going to discuss this now conceptually.
For this question, here they are asking the p-type semiconductor, which one of the following statement is true. First, we need to understand what is a p-type semiconductor and a n-type semiconductor. Then we can answer for this question easily. Suppose if you are taking the silicon or germanium semiconductor, suppose if you are taking silicon or germanium, it is having 4 valence electron. If you are keeping that inside the crystal structure, so each one of them having 4 valence electron. So what it will happen, the center atom will make the bond with the 4 nearest neighbor. In this crystal it's a diamond structure, so each atom having 4 nearest neighbor. So this silicon also will make the 4 bonding with the nearest neighbor because it's having 4 valence electron. This one also will make the 4 bonding with its nearest neighbor. So this one also will make the 4 bonding with its 1 2 3 4. This one also will make the 4. So 3 4. So it will repeats itself. So so this silicon atom will share one electron here, this silicon atom will share one more electron, so it will make the strongest covalent bond. That's why we can call this as a diamond structure. It is strongest structure. Now if you are adding pentavalent open and then trivalent open, what would happen to this semiconductor? It is called intrinsic semiconductor. There is no free electron because all the electrons are making bond. So we can call this type of semiconductor is intrinsic semiconductor. Intrinsic semiconductor or pure semiconductor or pure semiconductor. So there is no free electron, there is no conduction happening in the pure semiconductor. Suppose if you are just adding with the trivalent atom. Trivalent means that atoms having 3 valence electron, those atoms are we can call trivalent atoms. The example, boron, gallium and indium or aluminum. Suppose I am doping the center one with the aluminum, the 4 silicon atom will be there. 4 silicon atom because in this structure it is having 4 nearest neighbor. I am going to dope on the center atom. I am going to replace with the trivalent atom aluminum. Trivalence means it is having 3 valence electron, but silicon atoms are having 4 valence electron. So the silicon atom will be making bond with the 4 nearest neighbor, all the silicon atoms. Suppose this one also will make 4 bond with the nearest neighbor. This one also will make the 4 bond with the nearest neighbor. Even I am not drawing the all other atom, you can draw it. So here also it will make the 4 with its nearest neighbor. There are 4 bond each silicon atom. Now aluminum is having trivalency. So trivalence means 3 valence electron. Either it can make 3 bond 1 2 3 or 1 2 3 or 1 2 3 or 1 2 3 or 1 2 3. It's like that, but only one bond is missing. Suppose if it is making the bond with these 3 nearest neighbor, there is one vacant bond in this region. There is no bond because there is no valence electron available. So we can call this region is a hole. It is having the whole region. Still it is making the single bond silicon with the aluminum, but aluminum cannot make with the bond with the silicon because there is no more electron available for the aluminum to make the bond because it's a trivalent atom. So if you are adding with the trivalent with the semiconductor, the intrinsic semiconductor, it will create the extra hole. If you are putting like millions of aluminum atom, it will create millions of holes. So we can call this is we having excess holes. We can call this type of semiconductor is a p-type semiconductor. So when trivalent means 3 valence electron atoms added with the intrinsic semiconductor or dopant with the intrinsic semiconductor, then it will create lot of hole. That means vacant position of the electron, lot of holes. We can call this is p type semiconductor. P type semiconductor. So the answer would be, which one of the following is true statement for the p type semiconductor is the holes are the majority carriers when the trivalent atoms are dopant. So answer would be the B answer.
So from the above discussion, we understood the holes are the majority carriers when the trivalent atoms are the dopants in the intrinsic semiconductors. So the option B would be the right answer.